Alright, so we are here with question 7 of the November 2018 South African Syllabus CAPS exam for Matric Mathematics Paper 1. Previous couple of questions were graphs of functions questions, and now we have a finance question. Okay, so question 7 reads, Selby decided today that he will save 15,000 Rand per quarter over the next 4 years. He will make the first deposit into a savings account in 3 months' time, and he will make his last deposit at the end of 4 years from now. Okay, so first thing we notice is that it's 15,000 per quarter that he will save, right? So it's a regular payment. So we know we're dealing with future value and present value formulas. So let's just write them down. The future value formula is X, so that's your regular payment. And then we've got 1 plus the interest rate. Let's actually just write it a bit better. So 1 plus our interest rate divided by how many times per year it's compounded. Total compounding periods is an exponent, minus 1, and then all of that over the interest rate again. Right. Now for present value, pretty similar idea. We've got our regular payments X, then we've got 1 minus, and then 1 plus our interest rate divided by the number of compounding periods per year to the power of negative total number of compounding periods all over the interest rate again. Alright, so just to have that in the back of our minds, and then let's look at question 7.1.1. How much will Selby have at the end of 4 years if interest is earned at 8.8% per annum, compounded quarterly? Okay, so we need the future value at the end of 4 years. So for 7.1.1, we'll have the future value that Selby will have is the regular payments X, so that's 15,000 that he pays regularly. 1 plus, and the interest rate is 0.088 compounded quarterly, so 4 times per year. And for 4 years, that'll be 16 total compounding periods, right? 4 years, 4 times per year gives us 16. Minus the 1, and that all divided by the interest rate again. So 0.088 over 4. Okay, let's calculate this on the calculator. I think I have it here already somewhere. Well, maybe not. Okay, so let's just start from the beginning. So 15,000. Then we've got 1 plus 0.088 over 4 raised to the power 16 for 4 years, minus 1, and that all divided by the interest rate again, 0.088 over 4. Okay, oh, this bracket is the wrong way around, sorry. And that gives us 283,972. So 283,972.28. Right, and that's Rand. Remember to write your units. Okay, so that's what it'll have at the end of 4 years. Nice. Now let's look at the next question. 7.1.2. Okay, so for 7.1.2, if Selby decides to withdraw 100,000 from the account after 3 years, how much will he have in the account after 4 years? Okay, so a little bit more complicated. There is a really quick way to do this, but I'm going to show you a slightly longer way because I think it's more intuitive. If you found a shorter way, or you know how to do it, leave a comment in the comments and we can discuss that. And it's always nice to get different opinions on how to do things. Like I said, I'm going to show you a slightly longer method, which I think is just a bit more intuitive. So this method just says, well, we work out how much he has after 3 years, right? Then we subtract the 100,000, which he takes out. And now that value will obviously accumulate some interest over the next year. So we just do the normal compound interest formula for that, right? For the 1 year. And now that, so then that doesn't account for the 15,000 that he pays in still. So we still have to add the future value amount for that extra year, for the 4th year. And that future value amount will obviously be our x plus, or x and then 1 plus I over m raised to the n minus 1 over I over m. And now this will just be 1 year's value. So let's just calculate that. So first we need to do F3. So F3 equals, we're just going to do the future value thing for 3 years. So it's exactly this whole thing. Maybe I can just copy that, save some time. All right, so copy that. Copy this whole thing, and busy with this color. And now the only difference is we're working with just, working with just 3 years. So we're going to make that a 12. A 12. Okay, so that'll be F3, right? So that equals, let's just change this into a 12. And then we get 203,459, 203,459.12. 0.12. Okay, so that's F3. Then we want to subtract 100,000. Right, so that will give us 103,459.12. Okay, so that's this part. Now this is what it has at the end of 3 years. Now this will accumulate some interest, so that's why we use the compound interest formula. So 1 plus, the interest rate is 0.088 over 4, compounded quarterly, and it's just 1 year, so power 4. Okay, so that'll be this whole part. Let's see what that gives us. Okay, so we've got that minus 100,000, and then we're going to say, okay, raise that times 1 plus 0.088 over 4, and it's for 4 compounding period. So 112,868, 112,868 point, let's call it 40. Oh, 3955. I'm gonna just keep a few decimal places. 3955. Okay, so that is now this whole part we just calculated. Now let's do this part, right? So that part is just the future value, but only for 1 year. So we're gonna say the 4th year is 15,000. 1 plus the interest rate, 0.088 compounded quarterly, so divided by 4 for 1 year, so it's just 4 total compounding periods, minus 1 all over I over M. So 0.088 over 4. And let's use the calculator for that again. So let's just use, we had this already, now all the difference is it's just 4 here. Okay, so 62009, 62009 point, then we've got 19972, 19972. All right, so all we need to do is add them, right? There's a plus sign. So we just add these two values. Okay, so that plus, we had 112,868.3955. And we get our total of 174,877. So our rands is 174,877.60. So that is what it will have at the end. Okay, so like I said, it's a bit long, but at least it makes intuitive sense, right? You take the value after 3 years, subtract the 100,000 that it takes out, see what that accumulates, the interest that amount will accumulate in the year, in the 4th year, and then we do the future value for that just the 4th year by itself. And we add the two amounts, and we get our total. But like I said, there is a shorter way. Let me know if you found it. Good, let's get on to question 7.2. Okay, 7.2 reads, Tsepo takes out a home loan over 20 years to buy a house that costs 1.5 million. Okay, 7.2.1. So calculate the monthly installment if interest is charged at 10.5% per annum compounded monthly. Okay, so now this is a loan. So whenever you see a loan, you're going to use present value. Because present value means the total amount has already happened in a sense. So a loan, you've already gotten the 1.5 million. Now you have to repay that. So a loan will be present value if you have to repay a loan. Any installments that you have to repay. Or another one could be like if you win the lottery. So you've already won the $1 billion lottery, but they pay you out in installments. So the big amount has already happened, and now the installments just happen from there. So that's also a present value formula. So those are pretty much the two only things. The loan is the most common present value formula, and like I said, if there's something like a lottery that someone's won and it's just being paid out in installments, that will also be a present value formula. Okay, so let's write down our answers here. So we know the loan is for 20 years, so the present value we know is 1.5 million. So 1.5 million equals, and then the monthly installment, the regular payments, X, that's what we want to find out. And then the present value formula says 1 minus 1 plus, and the interest rate is 0.105 compounded monthly, so divided by 12. And that's raised to negative n. So it's 20 years per monthly. So 20 times 12 is 240. Okay, all of that over the interest rate again, so 0.105 over 12. Alright, now we need to get x by itself. So I'm just going to rewrite this and say first thing we do is we take this value, 500,000, multiplied by this bottom, the denominator here, right? So 0.105 over 12. So that's gone. Now we need to divide by this big bracket. So divided by 1 minus 1 plus 0.105 over 12 to the power negative 240 equals, and all that's left on that side then is the x. So we want to type this in our calculator. Oh, so finance is always messy, right? And you know that probably from your personal finances. It is a messy thing. Okay, so 1,500,000 multiplied by 0.105 over 12. And now that whole thing we're going to divide by the 1 minus 1 plus 0.105 over 12 raised to the power negative 240. Okay, 14975.70. 14975.70 equals x. So that many rands, just under 15,000 rand per month, is what he will pay to buy the house that's worth 1.5 million for a loan that takes 20 years to pay back. Great. Now, next question, 7.2.2. 7.2.2. So you see 7.1.1 and 7.2.1, both of them we just plugged our values into the present and future value formulas. 7.2.2. Calculate the outstanding balance immediately after the 144th payment. Okay, this one usually catches people out. I see a lot of mistakes being made in this type of question, finding the outstanding balance. So again, there's a really short method to do this. Again, I'm going to show you a slightly longer one because I think it just makes intuitively a bit more sense. Right, so the idea is we want to say A minus F. Right, and I'll explain what this means now. For an outstanding balance, this is what I like to do, A minus F. So A, that's our normal compound interest formula, and F is our future value formula. And we'll just do both of these for the 144 compounding periods and just calculate that. All right, so let's see what happens here. So A, we know our normal compound interest formula. So 1,500,000, and then 1 plus the interest is 0.105 compounded monthly, and this is for 144 months. Right. Now we want to subtract from that the future value. So we know the future value formula, we just saw it at the top here. Right? The future value formula is the monthly payments. What is the monthly payments? 14,975. 14,975.70. And then we open the brackets. We've got 1 plus 0.105 compounded monthly raised to the power of 144, so 144 payments, minus the 1, all over 0.105 over 12. Right, so that's the idea. Just do A minus F, right? That's for outstanding balance. I think it just makes sense because this is what it accumulates for that time, and this is how much you've paid during that time. All right, so let's work this out. Calculator time again. It's the only bad part about financial mathematics. You always have to do calculator work. Okay, so 1.5 million for the A part, 1 plus 0.105 over 12, all raised to the power 144. Okay, so that's the first part. I'm just going to do it step by step like this. So 525,929, 5259229 point, let me write a few decimals, 61396. 61396 minus. Okay, now let's calculate the other part. So that part is 14,975.70. Then we've got our brackets, 1 plus 0.105 over 12, all raised to the 144th power, minus 1, close the brackets. Ooh, so I have two brackets here. Let's do that. Okay, close the brackets, and we divide all of that by the interest rate again. 0.105 over 12. Okay, 2469. What is that? Oh, this is a problem. Sorry, that should be an exponent. Okay, 42893. 4289302. 47084. 47084. Okay, and let's just subtract them. So we had 5259229.61396 minus that, and then we get 9699927. 9699927.14. So final answer just two decimal places, because cents just go to two decimal places. So that will be the outstanding balance after 144 payments. So after 12 years, we'll still owe 969,000. So loans for homes are expensive, right? After 12 years, you haven't made much of a dent. All right, so that is it for finances. And I know it's quite messy to follow, but the idea here was just to look at what the formulas are for future value and present value. We use them over here and over here. And then the bit more complicated questions for each. What happens if you take some money out? If you change up the payment schedule? Well, then you have to split it up and calculate a couple different things. Like I said, for this one, there's a short method, and for this one, there's a really short method as well. So see if you can find those. Let me know in the comments below if you found them. But I did slightly longer ones that I think just makes a bit more sense of why they work and easier to remember because of that. So for this one, all we did was we calculate all the separate parts and work them out. And for this one, outstanding balance, I like to refer people to just do this. Normal compound interest minus future value. And that's it for outstanding balance. All right, and that's it for question 7, and I'll see you again for question 8.